おはようございます。前回配信からだいぶ間が空いてしまいましたが、また配信を開始していきたいなと思います。3月、4月、2月後半ぐらいからちょっと本業の方がめちゃくちゃ忙しくなってしまって、全然配信をする余裕がなかった状況が続いてまして、ゴールデンウィークでだいぶ崩れてしまったリズムを回復できたので、あと仕事もだいぶ余裕出たので、また気を取り直して配信していきたいなと思っております。ちょっとやっぱHoudiniはどうしても使えるようになりたい楽しいツールなので、本業では使ってないので、細く長く粘り強くやっていきたいなと思ってます。はい。で、今日は、なんか面白そうなソップのパーティクルのチュートリアルがあったので、それをやっていこうかなと思ってます。はい。Houdiniのバージョンは 18.5 ですね。で、レイアウトは、ビルド2というレイアウトを適当に作ってやってます。はい。では、動画を再生していきます。ちょっと久しぶりなので、配信はしてなかったんですけど、ちょくちょく手は動かしてはいたので、完全に触ってなかったわけではないんですが、久しぶりの配信なので、だいぶ下る可能性がありますが、よろしくお願いします。はい、ではやっていきます。ちょっとそろそろこの猫のありもののキャラクターも変えていきたいんですけどね。はい。ちょっと可愛いんで気に入ってはいるんですが。はい。では始めていきます。
Let's start. Let's place our geonode. Let's call it lines. And let's dive in. Let's start.
久しぶりすぎて動画がめっちゃ早く感じるな。俺こんな早かったっけ?
Placing some lines on the ground. So let's create an line. Okay. I think it's all right. We want our line to be on the floor. Let's use the z-axis. Okay. So we have our spline, our line. Let's make it 50 points. With 50 points, if we turn on the points, we can see all the points. And let's increase the length by 10. And it's okay. I want this to be in the middle, so let's use the length. Right click, copy parameter, and here paste relative reference, divide by 2. And we want minus, of course.
.真ん中にしてるだけ。 こが入ってる。
Alright, okay. So we have our spline in the middle. If we change our size, our length, we'll stay on the middle. Now let's create a grid and let's copy this little line with a copy node. Okay, so let's copy maybe 10 and we want to move it on the x-axis, space 1. Okay, this is way too big, so let's put it like 0.5, 0.25 for now. Okay, let's increase the number. Okay, maybe 0.2. Let's give one more. Okay, so we have like a little nice grid. I think the spline is way too big. Okay, so -2, from -2 to 2 on Z, and on X from 0 to 4. Okay, we can put this on the middle. So let me see if I can do this procedural. I don't think so. Let's place this -2. Okay, so we have our grid in the middle. Pretty cool. And now we have particles, right? We have a line with each line has 50 points, and let's place our pop net. Okay, let's dive in. First, let's use all the points. Instead of scatter onto surface, let's use all points. Okay, so now if we emit, I'm going to put a gravity just to show you. If I press play, we will emit particles on each point, and they will fall down because we have a gravity. Pretty cool, but we don't want this. I was just showing you. So let's delete the gravity, and now our pop source, let's change the bird impulse to our friend $f == 1. So we are going only to emit on the first frame. Okay, nothing happens now. We are emitting the particles on each point. And if we add a force, let's write pop force just to see if we have this working. See, our particles are going crazy with the pop force. Okay, I don't like to use the pop force. I want to control by myself the noise and the forces we have on our particles. So let's place a pop flop. The forces want to with a pop flop. Okay, our particles are going crazy with a pop force. Okay, I don't like to use the pop force. I want to control by myself the noise and the forces we have on our particles. So let's place a pop flop. Very cool. And let's dive into our pop flop. Let's add a curl noise. Okay, we have our P position wired to the position, and our noise we are going to wire to our force. Pretty cool. I want to promote 2 parameters, the frequency. Oops, wrong button. Alt middle mouse, promote parameter, and I want the amp to Alt middle mouse and promote parameter. So now we have these 2 parameters right here on the pop. Okay, But instead of changing the frequency like this, I want to put a parameter. Parameter. This is going to be a float. Let's write frequency noise. I want to be a float, okay. And I want to convert this float to a vector. I normally do this, so I hope you are understanding what I'm doing. So wire the float, the parameter frequency noise to all the parameters on the float. And like this, I can have a slider to change my,
綺麗に並ばないな。これで
slider to change my frequency. Okay, instead of writing the same number to each parameter on the frequency, because the frequency is a vector, you can have different frequencies for each axis. I want to just change here one thing, I think. Okay, now I have here frequency noise. I want the frequency really slow. I want the amplitude to 0.25, maybe something like this. With our particles. Up. I'm going to place a trail just to see what's going on. Connect has polygons, don't close, and let's place F end. Turn off the points. So we have our particles. Turn off end. Turn off the points. So we have our particles. Pretty cool. This is a cool simulation. I like these graphics. Maybe I'm going to render this out. It's really cool. But we don't want that, right? We want to use these lines and change these lines. So how can we do this? With a simple popnet. We have our particles, right? And now I need to connect them and make a polygon. I make a trail. It's going to like trail the movement of each particle, and we don't want that. We can use the simple add node. This is what Maxim showed on his past tutorial. He was emitting particles, and with a simple add node he could connect the particles. So what can we do here? We can link our add node and then go to polygons, and we can link them by group. Okay, but if we do that, you can see our particles are linked like we want, but we have a spline we don't want, because let me go here. Okay, we have this spline here on 2. You can see this is the start, it's going that way, and then the last point on this line is going to connect with the first one on the next one. So we have these little triangles. See, this zigzag of splines. We don't want that. We want just connect these particles on the same spline and then stop. Then connect this one with this one. We don't want this middle one. So how can we control this? I bet there is a better way to do that with maybe these copy number attributes. Or out. Let me try this one. I'm going to try this live on the tutorial. Let's. I'm going to try this live on the tutorial. Let's see this. No.
何が入ったの？コピーナンバーマイナス1だが、本当にこのパラメータ使えんのか。
Okay. This is going to be what we are going to try. But how can we control this? With a simple attribute. If you see it here on the add node, you can see polygons by group, and on add we have all points. But we can use attribute to link the particles. So if on each spline these points have the same attribute, like for example, like Maxim used in the connect attribute. So maybe connect attribute is like a number, and all these particles on the same spline have the same value for that attribute, that connect attribute. To be more simple, we are going to use the color of each spline. So how can we do that? Let's place a VOP. I love the VOP. Let's use a point VOP. Let's dive in. And we are going to color these splines by their axis, on the X axis. So let's convert vector to float, because we are going to use the X value of the position, vector to float. So wire the position to the vector. So we can have the first one, it's the X. Let's place a fit range. Okay. Let's promote all these parameters. Right click and then vexVOP, create input parameters. Okay. And let's wire these into a ramp. Simple as that. And let's ramp to color. As you can see, something is going on, right? Color. As you can see, something is going on, right? You can see black splines, gray splines, and white splines. Right now, the ramp takes values from 0 to 1.
見づらい。
So when the splines are bigger than or minus 1, 0, minus 0 or bigger than 1, they will stay the same value. So that's why we use the fit parameter. So on the let me increase this if we can see. No, we can see. On the minimum value in source and maximum value in source, we are going to put the values from our X. We know our X are going from -2 to 2, right? So let's place this up. So right now, each spline has a different color. Pretty cool. And because we are using a PopNet, our particles, if we turn off the guide, our particles will have the same color as the splines. Pretty cool, because here we are changing on the point warp, so each point has a color attribute. If we go, we check if we can see color attribute. Okay, you see each point has a color value, 0, 0.05, and then if you go to the next one, it's 0.1, and so on. Okay, so like this, I don't know what I'm going to do. So like this, if we control our particles behave the same way with the curl noise. But now on the add attribute, on add node, we can go to add attribute, and on attribute name, we can simply put the color. Pretty cool. So if I press play now, you see we have splines behaving with the PopNet force.
なるほどな。こいつをもっとプロシージャーにした方がいい気がするか。マイナス2の
Simple as that. Of course, now we can resample. Instead of having straight edge, I like to have subdivision curves, so we have more control and more smooth splines. And here on length, I like to have a really low value, 0.01. Pretty cool. Simple. So here we have points, 21 polygons. I'm sorry, I was speaking Portuguese. 21 polygons. And of course you can put a convert line like Maxim did. But I don't think on this case, we have more polygons now. Yeah, because it's case, we have more polygons now. Yeah, because it's converting all the lines. Previous lines, we have points and 21 polygons, and now everything is on polygons, as I can understand. Okay, pretty simple. So now it's up to you to play with the PopNet. Imagine you want the force to be only up. So let's convert our vector to float, and we don't want our y force to be minus than 0. We want to go up. So let's place an absolute. Okay, so we have only positive numbers. And let's convert again float to vector. On the x we want the previous one, on the z we want the previous, but on the y we want the absolute. So So let me go up a little bit. Now we have like a smoky animation. First, now we can control our popnet. Our amplitude is cool, but our frequency is way too big. I don't think that is cool. It's way too big. I don't think that is cool. Of course, now it doesn't work because the frequency is way too slow.
小さすぎじゃね。
Very cool. Imagine now you want to advect particles with a smoke, advect our splines with smoke. Before we do that, if you don't want to see all the gray again, let's place a color node just to paint everything white, and voila, everything is white. Okay, I was saying, imagine you want to advect, let me place a sphere, advect our splines with a simple smoke simulation. Cool. So let's make a sphere with 0.2 on uniform scale, and let's bring it down a little. Oops, not that. Here on center. Let's place -1. Maybe 0.5. Okay, let's use the shelf tool. Select the sphere node. Let's go to Pyro FX. Below is smoke. Let's wait a little. X shelf tool. Select the sphere node. Let's go to Pyro FX. Below is smoke. Let's wait a little. On the resize, I want to turn off clamp to maximum, increase the padding. Okay. On our division, the padding size, I want to turn off clamp to maximum. Increase the padding. Okay. On our division size, for now we are going to stay with 0.075. We don't need higher resolution or a smaller division size for this simulation. And on Pyro import, I like to use the top. Delete this one. Okay, and if I press play, let me turn off our lines. If I press play, we will have a smoke simulation. Cool. I like to clean this Pyro simulation. Let me reduce time. Okay, 0.25. 0.25, I have only 25%. On shape, 0.25, I have only 25%. On shape, I want less disturbance. Less turbulence and a little bit of confinement. Okay.
コンプルエントってなんだっけ？コンファインメントか。
And a little bit of confinement. Okay. I'm going to cache these okay, file cache. I'm going to rename it to smoke cache. See, I like to delete this heap name file. Okay, have only the node name and the frame. Okay. I like to delete this heap name file. Okay, have only the node name and the frame. Okay, and I'm going to cache this simulation, smoke simulation. Okay, be right back. Okay, so I've got my simulation. Okay, my smoke simulation. I'm going to load from disk so it can be faster. And then let's turn this off. We don't need this to see this one. And let's turn on the lines again. Sorry, I was with the zoom out. So we have our popnet, right? How can we control our particles with the smoke? So let's place a volume pop advect by volumes, right? And let me do one thing before. Let's go to pyro import. I want to place no and call it out smoke. Okay, let's go back to our lines, our popnet, and our pop advect by volumes. Let's pick up our null object. Not on the lines, it's on pyro import, out smoke. There it is, our null. So let's press accept. Now, if I press play, you'll see our particles are kind of exploding away. Cool. Of course, you can change these the way you want, like update velocity and dial this down. Maybe it's going to be more smooth. Not that smooth. Let's see the drawing. Of course, this is it is done really fast, so the simulation is kind of bad. But here you get the idea. You can use smoke to control your simulation. Your popnet, it's going to be super fast, even if I increase the air resistance. Of course, this smoke simulation is really simple, but you get the idea, right? Pretty cool. Of course, this is for a line, and you ask, how do you use this point VOP color node, right, with a 3D object? Because this one is a simple, let's call it 2D. Grid, right? So let's try that with a sphere. So we have our sphere. Let's change this to polymesh, so we have like a simple grid. So as you can see, if I turn on the points, you can see each line has a point, right? So like this, we can use the point VOP again, right? But of course, now we are not going to use the x-axis. We are going to use the y-axis. We want to paint from down, from the bottom to our up, to our top. So now we are using the y-axis. Now it's not from -2, it's from -1 to 1. Right? And let's dial back. Let's wire this back, our point VOP. I like more the curl noise. So if I turn this on, you can see now we are emitting particles on each point on the sphere. And of course, if we turn on the add node, it is going to have that, okay? Of course, you can close this gap with this closed one. Okay, with this close. Now we have like a grid. This is cool. I'm going to try this on a different animation. Let me play with this a little bit. Increase. Let me go back to our sphere. Increase the rows and the columns to 50 or more, 100, and this to 100. It's going to be cool. Pretty cool animation, huh? The possibilities are amazing with this little trick. I think this is going to be too much wow. But it's cool. Okay. Now our convert lines get back our lines only, without that polygon. Pretty cool. Let me see all the animation. Super slow. Pretty cool. It was super easy, right? Big thanks to Maxim for explaining this little trick with the head node. Hope you enjoyed this video. See you on the next one.
で、どの程度応用できるんだろう。テストジオメトリ使ってみるか。はい。とりあえず、一通り、これで動画の作例はできました。なんか割とこう、ラインにして、オブジェクト、モデルをこうラインにして、輪切りでなんか作るみたいのっていうのが、結構この作り方面白いなと思ってやってみました。なんかこう簡単にやるときは結構、なんだろうな、スフィアメッシュで、やばい、久しぶりすぎてちょっと忘れてるな。ラインで、コピーで、違うか。じゃなくていいか、これ。グリッドか。グリッド作って、コピーで、複製して、これを、なんだっけ、やべ、忘れた。ブーリアンか。どっちがどっちだ。まあ、こうやってシームで 切ってあげれば、割と簡単にできるので、まあこっちでやることが多いんですが、なんかこっちのやり方は結構面白いなと。まあこっちのやり方っても割となんかそういうもんだという感じで、イディオムみたいなもんだと思って、小ネタみたいに使うようなやり方だと思うんですけど、まあこっちは結構ちゃんとプロシージャルに作ってるなという。ただまあこの中のポイントボップじゃないか、ポップネット、ポイントボップか。ポイントボップで、まあミントバリューをまあオブジェクトによって変えたりとか、その辺が出てくるので、X にするとうまくいかないんだ。ラバートイとか使うとどうなるんだろう。11だからマッチサイズかまして、これでいいか。サイズ2でマイナス。なんでこんなちっちゃいんだこいつ。あ、そっか、サイズ2か。こうか。これでかますと。メッシュは結構揃ってないと使えなさそうだな。やっぱりそうすると、なんか一回ボクセルとかに変換してきれいに並べた方がいいのか。でと、DB。と、何しようとしたんだっけ。均等のポイントを並べたいんだから。 と待ってよ。ポリゴンでいいとっけ。やばい。完全に忘れてる。ISO の方がいいのかな。ISO セットでスキャッターした方がいいんだっけ。で、完全に忘れている。なんだっけ。そうっすか。そうっすか。そうっすじゃないな。ダメだ。完全に忘れた。どうしても思い出せんぞ。いや。ちょっと、やろうとしてたのが、やろうとしたことを忘れてしまったので、後でちょっと、この後やってみようと思います。結局、ポイントが全部同じ高さにないとダメなので、複雑な形状だと、ポイントの高さがバラバラになってしまうんで、結局、この辺のラバートイとかつなぐと、この辺が高さがばらつきがあるのでうまくいかないということだと思うので、多分一回パーティクルに変換してポジションを全部、近いポジションを全部横並びにしてあげればできる気がするんですが、なんか簡単にそれをノードでできた気がするんですが、もう忘れたので、ちょっと後でやってみようと思います。テストヘッドの方がまだ綺麗かな。うん。まだ綺麗だか。これだと。そうな。一応になってないからもううまくつながんないよな。ちょっとこれをいろんな形状に応用するのは一工夫必要そうだな。こうなってないと無理だよな。トーラスだったらいけんのか。トーラスはいけそうだ。つなが ってんのが、ここはなんでつながるんだ。ちょっと汎用的に使おうと思うと、もうちょっと考えないといけなそうだな、これは。えーっと、レンダリングの最低限だけ見ておらせるか。あ、間違えた。作っちゃった。何これ。これは何だ。まあ、いっか。一旦、こんなところにしとこう。はい。とりあえず、レンダリングまで軽くやってみたので、一旦、今日はこれで配信終わります。ありがとうございました。